All right, guys. I know that some of you have been missing over the last couple days just due to different stuff. So what I wanted to do is I wanted to create a a video that just kind of is a quick synopsis of what we're doing over the last couple days. We've looked at lesson 1, investigation 2, which deals with characteristics of polynomial functions. And so I'm going to go over a couple examples. 2 of them come from the notes at the end of Investigation 2. That's what we're going to be looking at is 13 and 14 in Investigation 2 notes. And then there's one extra problem just to kind of put everything together over what we did. This is just a quick version of that. So we're looking at an equation. We have a function that has zeros. So if I were to look at my graph, I have some zeros. And remember, zeros are where the graph hits the x-axis. Okay? It has 1 at -3. It does have another at +2. And then it has another one, it says, at -4. Okay? And there are a couple things that this problem is telling us. Okay? We have one here, we got one here, and we got here another one at 2. It tells us that -3 and 2 has a multiplicity of 1. Okay, and then it says that at -4, it has a multiplicity of 3. So what that multiplicity is telling us is when I look at this polynomial, and a polynomial has the form of like x minus h and x minus k, and these are all the zeros, and that keeps going on. What this is saying when we talk about multiplicity is when it has a multiplicity of 1, that's saying that the power that each of these binomials are taken to are to the first power. So when it says that we have a multiplicity of 3, that is talking about how that binomial, or like that equation that gets me that 0, is going to be taken to the third power. So when I look at this general form, I know that there's always going to be an a value that we're going to multiply everything by, and I'm going to take x minus each of these zeros. So it says that one of the zeros was at -3, so I'm going to do x minus -3. It says that another one is at 2, so I'm going to subtract x minus 2. And then it says that the other one is at -4. Okay? And what it tells me is that when I look at -3, that is being taken to a power of 1, and also at 2, it's being taken to a power of 1. But when I look at -4, that 0 has a power of 3. So right now, if I look at this general form, it's going to be x plus 3, x minus 2, and then x plus 4 to the third power. That's the polynomial that we're looking at. Now I have to figure out what the a value is that's going to get me this polynomial. And that's where it tells me that it gives me one specific point on this graph. And that specific point is g of -8, which equals -128. So what I'm going to do is I am going to be plugging an x value of -8 into this equation, knowing that my y value is going to be -128. So I have -128, and then I have a. I'm going to plug -8 into this equation. So I got -8 plus 3, and then I got -8 minus 2, and then I have -8 plus 4, and that is going to be taken to the third power. So now I'm just going to do some math here. I got -128. I got a, I got -5, I got times -10, and then I got -4 to the third. If I do -4 to the third, I get -164. So I have -5 times -10 times -64. So I'm going to multiply all these values together. I'm going to take -5 times -10 times -64. And when I do that, I get -3200. So I got a times -3200. Now, if I want to get a by itself, I'm going to divide both sides by -3200. So when I take -128 divided by -3200, I get 0.04, which is the same thing as 1/25. That is my a value. So I know that in this function, g of x, my final equation is going to be 1 over 25, and then I got x plus 3, I got x minus 2, and then I got x plus 4 to the third power. That's going to be my factored form for that specific problem. Okay? So let's look at number 14. Number 14, it gives us similar information. Let's just kind of go through it. It has a 0 at 1. It touches and bounces off the x-axis. When we know that that's a case, I know that the multiplicity for this one is going to be even. Anytime that I have a multiplicity of an anytime that I have a multiplicity of an even number, I know that my graph is going to be bouncing off that x-axis, or that x-axis. So it's either going to be going back up again, or it's going to be going down. And that's what we're going to have to figure out. Okay, so we have 1, 0 at 1, and then we also have another one that crosses at -5. Okay, and it goes through. So why is that important? That tells me that this multiplicity is going to be odd in this case. Multiplicity is odd. So when I look at this, right now my general form is going to be h, or my factored form is going to start off as h of x times a times x minus 1, because that's one of the zeros, and then I got x plus 5, and I still have to figure out what those powers are. So I know that those powers for x minus 1 has to be even. And then when I look at x plus 5, that tells me that that power has to be odd. When I add those two powers together, it's going to get me the degree of the polynomial, which is a 5th degree. So, I mean, there's lots of different options, but I'm going to probably go with 2 for the x minus 1, and I'm going to go with the 3 for the x plus 5. That's 2 plus 3 gets me a degree of 5. Now, I could also choose 4 for x minus 1, or I could choose 1 for x plus 5. Either of those are going to work, okay? All right, so, but for this example, we'll just use 2 and 3. Now, I look at this, I know that I have a point at -3, 9.6, so I'm going to plug that in. So I got 9.6, and then I got -3 minus 1 to the second, and then I got -3 plus 5 to the third. So I end up with 9.6. And then I got a, I got -4 to the second, and then I got 2 to the third. So I got a, I got times 16, and then times 8 is going to equal 9.6. If I take 16 times 8, I get 128. So I got 9.6 equals 128. Okay, I'm going to solve for a. So I got 9.6 divided by 128, which is going to get me 0.0775, or 3 over 40 is what a is going to be. So in this situation, my final factored form would be h of x equals 3 over 40, and then it's going to be x minus 1 to the second, x plus 5 to the third power. And that's going to be your factored form. Okay? So I'm going to take a big jump here. I know I got a couple more minutes left. So let's look at one other problem. And in this case, I'm looking at a graph. I have 3 x-intercepts. I have one at -2. I got one at +2. And then I got one at 2, 3, 4, 5, and 6. I know in this case that at 2, or at -2, it's an even multiplicity. And then if I look at these other ones, it has an odd multiplicity. In this question, it tells me that it's a quartic, which means that I have a 4th degree polynomial. So when I look at this form, I know it's going to be f of x equals a, and then it's going to be, the first one's x plus 2, because the x-intercept is at -2 to the second power, and then I got x minus 2 to the first, and then the other one is going to be x minus 6. So that's my polynomial. I want to find out what what the a value is. So I'm going to plug negative 2079 into this in place of f of x. And then I got a, and then I got negative 5 plus 2 to the second. I got negative 5 minus 2, and then I got negative 5 minus 6. And I'm going to do some math here. I got negative 5 plus 2 to the second, that's 9. Negative 5 minus 2 is negative 7. Negative 5 minus 6 is negative 11. By 9, negative 7, and negative 11 together, I get 693. I'm going to divide both sides by 693. And when I do that, I get my a value to be negative 3. So my factored form is going to be f of x equals negative 3, and then it's going to be x plus 2 to the second, and then it's going to be x minus 2, and then x minus 6. That's going to be your factored form in this given situation. Okay? Let's look at a couple other things. I'm going to look at local mins and local maxes. What I'm going to do is put this equation into my calculator. I already had it populated in there. I'm also going to look at my window, and in the graph, it kind of gives me some key pieces of information. So I'm going to make sure my window is this way. You can pause the video if you want to make sure that your window is set up. So when I look at my graph, it's going to look pretty similar to what the one that's on your piece of paper. But I want to find the mins and I want to find the maxes. So what we're going to do first is try to find out what the minimum is. So I'm going to press second, and I'm going to press trace, and I'm going to go to minimum. And what we're going to do is you can see the blinker in the middle. I'm going to go to the left of that minimum. I'm going to press enter. I'm going to go to the right of it, and I'm going to press enter, and then press enter again so it can find its min. So you're going to see that I have a minimum at 0.43 and negative 154.9. So the next thing that we're going to do is I want to find the maxes. So in this case, that one's pretty easy because I know that that's a turning point. So I do know that I have one at 2,0. Let's try to find out what this one is. So I'm going to go second and trace. I'm going to go to max, which is going to be 4. And we're going to follow the same procedure we did for the min. So we're going to go to the left of that max. I'm going to press enter. And then I'm going to go to the right of it. So I'm going to go up above it, and I'm going to go to the right of it a little bit. Press enter, enter again. So you guys get another maximum at 4.56 and 475.93. So I'm going to look at the final piece of information. When I looked at this point, when I looked at that minimum, it's considered to be local because it is, in that case, it's not the absolute lowest point. It is just a low point on my graph. When I look at my max, I got two maxes, one at negative 20, which is my local. It is a high point, or it's a mountain point, but it's not the absolute highest because that is this point right here. So that's information about the local mins and maxes. The last thing that we want to look at is just talking about the idea of end behavior. So we always start off with these two pieces of information, talking about how x goes to positive infinity and how x goes to negative infinity, and just talking about what's happening with y. In this case, y are both going down low. All right, they're both getting smaller and smaller, which means that they are both approaching negative infinity. So your domain, x, as x approaches positive infinity, y approaches negative infinity. As x approaches negative infinity, y will also approach negative infinity. This is your Cliff Notes. This took a whole day and a half to do, and I got it done in about 15 minutes. Have a great day, and see you when I see you.